You don't want to put us.
The MedBricks webcast is focused on bringing distinguished Indians and others from diverse fields of science, medicine, technology, and philosophy to learn from each other and to create a new understandings and foster new ideas related to healthcare.
Hi, everyone. How's it going? Tonight, it is my pleasure to introduce Ramana Anamraju and talk to us a little bit about Science Must Style, which is a collection of 3 minutes that Ramana has written. And tonight we're going to talk about Paul Dirac, so it's really exciting. Ramana has a master's in physics. He studied nuclear engineering and computer science. He's got many years of experience in the healthcare field. So he is extremely talented and very intelligent. And so I will let Ramana take over tonight and talk to us a little bit about Paul Dirac.
Thank you, Jennifer. Thank you, Jennifer. I appreciate it. Jennifer Niemeyer is from our company for medicine. She lives in Omaha, Nebraska. So anyway, she is a long distance broadcast. This is international. Good morning, India. Good afternoon, England, and good evening in California and West Coast, and in bedtime in East Coast. So we have a world audience. We are in 7 channels. That we are broadcasting in all over the world. We are in Amazon Live in India. We have a Twitter Live. We are in Facebook Live, LinkedIn Live. We have YouTube Live, and all the major streaming platforms we are on. So this is going to be another new kind of healthcare media channel. Is going to be, that this is going to be uh, this is going to be about positron emission tomography, PET CT scanner. They use it quite a bit in the healthcare industry, particularly to detect cancers and tumors. This is a new tool, a relatively new tool. In the 80s and 90s, it started it. It's a relatively new tool. It is a powerful tool. It gives you the functional side of the cancers. Our goal is to introduce concepts to broad spectrum of people. So people who are in healthcare, doctors, nurses, and healthcare allied healthcare staff, they know about something about physics and mathematics and science. People with the physics and mathematics background, they know a little bit about healthcare. Just the introduction. So you have to do your own research and expand your horizons, understanding more. This is our goal. Okay. Let me start the story of positron. Is a remarkable man behind it. This is, but this is a book I have written. Science is not a subject. Science must be lifestyle, as Jennifer said. So, um, So when 14 billion years ago there was a Big Bang. Big Bang is the beginning of our universe. At the beginning of the universe, we are in after a short time, immediately after a short time, there is enough equal amounts of matter and antimatter were produced, equal amount. So matter and antimatter, I will explain to you how the antimatter looks like, but they are two equal amounts, exactly equal amounts are produced. But the mystery of physics at this time now is we don't know where that antimatter is gone. We don't have the address of that place. We hope we don't get it all of a sudden seeps into it and destroy us. It's like an evil twin. It is so strange. So if you see you in the mirror and the person in the mirror, person in the mirror, person in the mirror is a different person than you are. Okay, so person in the mirror is somebody who is supposed different from you are. Exactly looks like you. That's a very spooky, right? It's like a strange and weird. Not only strange and weird, it's a spooky. It scares the hell out of you. So, but you never wanted to meet that evil twin because when you meet that matter and antimatter get together, is a destruction. Is the amount of energy, everything is destroyed. So, so what we are trying to do is this beginning of the universe. There was a matter and antimatter were produced equal amounts, but we don't know where that antimatter is gone. But we see the antimatter in a lot of places. For example, you see that we produce, the bananas produce one positron, antimatter particle. Positron is a exactly opposite of electron. It's a positively charged electron, same amount of mass, the same charge, is same amount of same charge, but the exactly opposite of electron is a positron. It's a positive charge. Electron with a positive charge is called positron. So bananas, actually every banana emit every 75 minutes one positron is because potassium 40 is a radionuclide, radioisotope, radio source. So it produces the positron every 75 minutes from bananas. We also produce 200 positrons per hour in our body. They're so minute. I mean, you cannot, if you want to know what the cost of the 1 gram of antihydrogen is, you cannot think of the money it costs. $65 trillion. So it is a think about that. So they try to produce some small amounts, very very much smaller than a milligram. They contained in the container. Actually, they stored in a container for a few seconds. That is a lifelong in the history of physics. But that is the antimatter exists. We see it. So in this picture, what you see is the antiproton, antihydrogen. Sorry, there is the antiproton. Is a negatively charged antiproton. The hydrogen atom is one positive proton in the middle center, and the electron, negatively charged electron, moves around in the proton. In the antimatter, antihydrogen, it is a proton, antiproton, which is negatively charged, and the positron, which is positively charged electron, moves around it. So they're exactly mirror images of each other. So kind of in that sense, but it's not a mirror image in the sense that is a charge wise they're entirely exactly complementary and opposite. So there is a gentleman. His name is Paul Dirac, a British physicist. He is a remarkable man, very quiet. He's not a well known. He is very well known in circles of physics. Everybody knows Paul Dirac, if you study physics. But outside of the physics, not people don't know much about him. The reason was he's a very quiet. In fact, he doesn't make any noise. He speaks one word per hour, they say. So he was trying to understand Einstein and the gravity and special theory of relativity by Einstein. So he was playing with his mind. His mind is always busy. He's not speaking with his mouth, but he's always busy with his mind. So he's filled with the mathematical equations in his brain. So he came up with a one brilliant equations that the existence of antimatter, proof of and positrons, antimatter, anti-electron. But he kept it under his table for 3 years. He was not sure. Nobody even an idea about the antimatter at that time. So he doesn't want to be embarrassed, or he doesn't want to be. He doesn't want to feel, humiliated before the peers. So yeah, I think he kept it under for 3 years. He kept on checking and checking. Eventually, he released in 1929. He released that equations and he verified, and it came out that is existence of electrons. The existence of electrons, the positrons, was proved. That equation is a theory article. His imagination said that there is an antimatter exists. There is an anti-positron there. So through is a mathematical equation. That is the power of mathematics, logic, and reason, and the power of science itself. So after doing that, so for that call in Caltech, they proved April 26, 1932, after 4 years from after he predicted the antimatter. Caltech, Carl Anderson, experimentally saw a positron. See that the top one is electron going other way, and positron, same mass, same thing, is going the down. That is exactly opposite of going, they're diverging. So that's the existence of the proof of existence of positron. So it's a Wilson chamber. They do the chamber in the ionic chamber. They do that is a actual picture of the positron existence, first one. So I mean, before I go into the little bit of a PET CT scan around the story about PET CT scanner, right? So, but I need to understand a little bit about electromagnetic spectrum. Electromagnetic spectrum is basically photons with the same speed with a different wavelengths. So if you find the gamma rays, they treat the cancer, that is high frequency, the same speed. But high frequency means it is covering a lot of distance, moving shorter distances, moving. Okay. So the peaks or amplitudes, the peaks are much closer. If you go to the X-ray, the next one is X-ray. I'm going right to left. The next one is X-ray. Is that is X-rays that are from the photon. They're all photons, basically exhibiting a different wavelengths. That's all it is. The electromagnetic spectrum is photons exhibiting different wavelengths. That's it. So if you go ultraviolet, that's why sometimes ultraviolet. That's why you use those glasses, googles. So that's protect you from the seeing the ultraviolet ray, absorbing ultraviolet rays. A lot of skin cancer is possibly coming from ultraviolet rays too. The visible light is actually, they're all made it equal, but visible light spectrum is extremely smaller. What the wavelength we see, what we see is a very small portion of the wavelength that we see. We don't see too much wavelength. That's why is a visible wavelength is very small. The right side and left side we cannot see. So then it's the infrared waves. Infrared waves are that where the sun is coming, heating of the sun. That's the reason we feel hot. That is because of the heat coming from that. That's a longer wavelength. Microwave is the next one. Is you cook microwave, and all the microwaves are all done through telephone. There are microwave radiation, microwave antennas. Microwave is basically is a longer wavelength than infrared. It is that's what we use in the photons are going longer wavelengths. That's what it means. So the one we are using is infrared in the PET CT scanner is the other one, all the way the longest wavelength. That is what we use for the particle access for the PET CT scanner, PET scanner. So these are all the same photons. So particles have a strange quality. Their photons are photons. You're defining. I'm saying it is a particle, but it is a duality, particle and wave duality. It exhibits both characteristics same time. Is a both a wave and a particle same time. That's a mystery of one of the physics mysteries. So, so I wanted to say radio transmitter. This is where the chemistry comes in the picture. So the cancers now we talk. Let us talk about how they use these the PET CT scanner, how they use it in the to detect cancers. So in the glucose, the cancers consume a lot of glucose. They are very voracious consumers of glucose. They like a lot of sugar. So that is a sugar structure on the left side. You see. So on the right side, they call it chemical analog. So what they do is they take it out the OH in the bottom and you knock it out and put the fluorine. That's called fluorodeoxyglucose, fluorodeoxy FDG in short term they call. So it is a both. FDG is exactly the same as the glucose. The body thinks when they see FDG, body thinks it is a glucose, but it has something special. It has a radio transmitter inside. That's the 18F. Is a radio transmitter. It is basically it's not a radio. It produce. I tell you how it produces the radio. It produces the once it you consume it, once they give injection, it goes inside. It produces the positron. That is the function of the FDG. So you will know where the cancer when it consumes a lot of things. It consumes. Cancer consumes a lot. The cancer cells consume voraciously a lot of sugar, so they consume hence they consume FDG. That's why they give a FDG. Yeah, I'm getting a little problem here. Okay. So these are FDGs. These are molecule radioisotopes. They're a highly regulated industry, and also Nuclear Regulatory Commission monitors these things. Because it could be used for bad things like nuclear bombs and something like radioactive devices, or people wanted to put. One of the guys that put a poison in one of the guys' tea. That is a polonium. Actually, that's what they use. It is a radioactive isotope. You can produce